All right. This time I will give you this question. What kind of sequence is the following? If I have 3, 6, 12, 24, 48, and so on, how did we get the second term, the third term, do you think? And so on. If you could see from here, if we divide the second by the first, 6 divided by 3, we get 2. If we divide the third by the second, 12 divided by 6 will also give you 2. 24 divided by 12 gives 2 as well. 48 divided by 24 gives 2. So if you could notice, if we divide a certain term with the term immediately preceding it, we get that constant value of 2. Hence, if you have this kind of sequence, then it is an example of what we call geometric sequence. And you might ask, what's a geometric sequence? How do we get the succeeding terms of your geometric sequence? So these are just some of the things that we will be discussing for today's video. A great day to one and all. I am Mr. Kim J.C. Ensho, a faculty member of Iloilo National High School Special Program in Science, Technology, and Engineering, and I will be discussing with you today geometric sequences. I hope your paper, your pens are ready. Try to solve these exercises later on, and hopefully you will be learning something from today's discussion. So, as a quick recap, what is a geometric sequence? Let's call it GS for now. A geometric sequence is a sequence in which the quotient between any two consecutive terms is constant. This constant is what we call common ratio. And if you have a geometric sequence, for example, let's say we have a finite geometric sequence with terms a sub 1, a sub 2, a sub 3, a sub 4, then if you divide the second by the first, the third by the second, the fourth by the third, and if you will continue the pattern, if you divide a sub n by a sub n minus 1 with a term immediately preceding it, then you have to get a constant value. And this constant value is what we call common ratio. And take note, if there are ratios that are not equal, and if there is at least a pair of ratios that are not equal, then it is already a sufficient evidence to say that the given sequence is not geometric. All of these should be constant. If not, then the given sequence is not geometric. So let's have a quick exercise. Write yes if the sequence is geometric, and write no if otherwise. If you answered yes, indicate the common ratio. Let's have the first one, -5, -10, -20, -40, and so on. If you could see, -10 divided by -5 is 2. Remember, negative divided by another negative number yields a positive number. -20 divided by -10 is 2. -40 divided by -20 is also 2. Hence, this is a geometric sequence since you have a common ratio. So it's yes with a common ratio of 2. Because if you divide a term by the term immediately preceding it, you get a constant value, which is 2. How about this? -729, 243, -81, 27, and so on. You could see from here, the signs are alternating. And if you divide, but the thing is this still geometric? or not? 243 divided by negative 729, it's negative 1/3. Negative 81 divided by 243 is also negative 1/3. 27 divided by negative 81 is still negative 1/3. So yes, this is geometric with a common ratio of negative 1/3. I hope you got it. And if you did, great job. Letter C. 27, 18, 12, 8, 16 thirds, and so on. So this is again, yes, this is geometric because if you could see, 18 over 27 is 2/3. 12 eighteenths is 2/3. 8 over 12 is 2/3. 16 thirds divided by 8 will make it 16 thirds times 1/8, which is still 2/3. So again, yes, this is geometric with a common ratio of 2/3. How about the fourth one? 4, 4 squared, 4 cubed, 4 to the fourth, 4 to the fifth, and so on. So if you could see, if you divide 4 squared by 4, 4 squared is 16 divided by 4, that's 4. 4 cubed is 64 divided by 4 squared, that's also 4, and so on. If you wish, remember, if you divide a certain expression, certain expressions having the same base, and if the exponent of the numerator is greater than that of the denominator, all you have to do is you have to, for example, if you have 4 to the fifth divided by 4 to the fourth, you will subtract you will copy the base, the common base, which is 4, and subtract the exponents, 5 minus 4, which is 1. So 4 raised to 1, or simply 4. How about for letter E? 8, 8x squared, 8x to the fourth, 8x to the sixth, 8x to the eighth, 8x to the 10th, and so on. If you could notice, if you will divide 8x squared by 8, it will give you x squared. 8x to the fourth divided by 8x squared will still give you x squared. You will divide the fourth by the third, it's also x squared. The fifth by the fourth, the sixth by the fifth, you will also get x squared. So this is again a geometric sequence with a common ratio of x squared. But again, x here should not be equal to 0, or else you will have an undefined expression if you divide the second by the first, the third by the second, and so on. How about for letter F? 5, 10, 20, 80. Is this geometric? If you could see, 10 divided by 5 is 2. 20 divided by 10 is also 2. But if you could see, 80 over 20 is 4. So you could see that there are ratios that are different from the others. So this one is a no. It is not a geometric sequence. I hope you got it right. And if you did, great job. So what can you say about, based on the activity that you just did, what can you say about the signs of the terms? Remember this. If the common ratio is greater than 0 or is positive, then expect that the signs of the terms is the same all throughout. Meaning to say, all of the terms are positive or all of the terms are negative. How about if the common ratio is less than 0 or is negative? If you could see in the previous exercises, if you have a common ratio that is negative, then expect that the terms are alternating in terms of signs. For example, if your first term is positive, that's plus minus, plus minus, plus minus, and so on. If your first term is negative, then the terms will be negative, positive, negative, positive, negative, positive, negative, positive, and so on. That's why I hope that this is something that you should take note. Simple things, but they could create but they are very helpful as well. How about if the common ratio is 1? It actually tells us that the resulting sequence will have terms that are constant. For example, if your first term is 3 times 1, so that's 3 times 1, 3, and so on. Remember, if you are going from right to left, 3 divided by 3, 3 divided by 3, 3 divided by 3. But if you are going from left to right, we are actually multiplying with your common ratio. So with such, but remember, it's kind of boring if all the terms are the same. So for most part of our lesson, we will have our common ratio not equal to 1. And of course, we will have also our common ratio not equal to 0. Because if our common ratio is 0, then all the term, especially the succeeding terms, would be 0. And if you perform division, then you will get undefined results. So for our class, more often, we will set the common ratio as any real number, but not 0 and not 1 most of the time. I hope it's clear with us. So let's talk about the recursive formula of a geometric sequence. I hope you could still remember when we speak about recursive form of a sequence, you are actually utilizing a term to get the value of a succeeding term. Let's take for an instance the geometric sequence 3, 6, 12, 24, and so on. If you could see here, the first term is 3, and the common ratio is 2. Take y2. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is also 2. Or you could also say 3 times 2, 6. 6 times 2, 12. 12 times 2, 24, and so on. You could see that the second term is 6. But we see that from the first term 3, we multiplied 3 by 2. That's why I expressed 3 times 2. And you could see that 3 here is the first term. So I replace 3 with a sub 1. And your 2 here is your common ratio. So I replaced 2 with r. So a sub 2 is equal to a sub 1 times r. For a sub 3, which is 12, the term before 12 is 6. And to get 12, we multiplied 6 again by 2. So from here, I express 12 as 6 times 2. But 6 is the second term, right? So I replaced 6 with a sub 2. And the 2 still is your common ratio. And for the fourth term, which is 24, using the third term, you multiply 12 by 2, right? But 12 is the third term, which is your a sub 3. That's why 12 was replaced by a sub 3. And 2 again is our common ratio. So take a look. A sub 2 is a sub 1 times r. A sub 3 is a sub 2 times r. A sub 4 is a sub 3 times r. With such, if we will generalize the pattern for a sub n, you could actually see that a sub n is equal to a sub n minus 1 times r, where a sub n here is the nth term of a geometric sequence, and a sub n minus 1 is the term immediately before it or immediately preceding it, and r is our common ratio. So this is the recursive relation or the recursive form or formula of a geometric sequence. Now, let's solve this short exercise. Consider the geometric sequence 3, 6, 12, 24, and so on. Find a sub 7 or the 7th term. We have r equals 2, right? That's given. I think we ascertained it earlier. 24 is the 4th term. And to get the 7th term, we need to get the value of the 5th and the 6th. So if we have a sub 5 and following the recursive formula earlier, a sub 5 is actually equal to a sub 5 minus 1 or a sub 4 times r. But a sub 4 is 24, so 24 times 2, which is your r, is 48. So 48 is our 5th term. For the 6th term, it's equal to the 5th term times the common ratio. The 5th term is 48, so 48 times 2 will give you 96. And for the 7th term, it's equal to the 6th term times your common ratio. Your 6th term is 96 times 2, that gives you 192. Thus, the 7th term of this geometric sequence is 192. I hope you got it. Now, as what I would always say in class, sometimes it would be better not to use the recursive formula, especially if you are getting a high subscript term, the term with a higher subscript of this particular sequence. Hence, it's better to discuss the explicit form of a geometric sequence because this will be often used in our class. Now, let's consider the same sequence. If you could see still, the first term is 3 and the common ratio is 2. From here, we could see that a sub 2 is 6. And our basis will be the first term. You multiplied the first term with a common ratio 1. So that's why I have here 3 times 2, which is a sub 1 times r, because 3 is your first term and your r is your common ratio. To get to the third term, from the first term, you could see that you multiplied 3 by the common ratio 1, 2. You multiplied 2 twice. That's why I expressed 12 as 3 times 2 squared. But 3 is a sub 1, and your 2 here is your r squared. So a sub 3 is equal to a sub 1 r squared. If you have the fourth term, which is 24, from the first term, how many times did you multiply the common ratio? You have times 2, times 2, times 2. You multiplied the common ratio thrice. Hence, I express 24 as 3 times 2 cubed. And replacing 3 by a sub 1 and 2 by r, we have a sub 4 is equal to a sub 1 r cubed. So take a look. If you have a sub 2, that's a sub 1 times r in general. A sub 3 is a sub 1 r squared. And a sub 4 is equal to a sub 1 r cubed. And if we will continue the pattern, we could actually see that the exponent of r here is 1 less than the subscript of your a. Hence, the nth term of your geometric sequence is defined as a sub n is equal to a sub 1 r to the n minus 1, where a sub n is the n term, a sub 1 is the first term, n is the number of terms, and r is the common ratio. I hope you got it. And if you got this formula as well, and if you derived it as well, great job. Now, let us use this explicit form to answer the similar problem we had earlier. Consider the geometric sequence 3, 6, 12, 24, and so on. Find the 7th term. You could actually see that the first number here is 3. So a sub 1 is 3. Just subscript of your a is 7. So this is your n. We are looking for the 7th term. So n is 7. And again, the common ratio is 2. We are looking for a sub 7. And utilizing the explicit formula a sub n equals a sub 1 r to the 7 minus 1, you will actually get a sub 7 equals 3 times 2 raised to 7 minus 1. We have to remember that this becomes 3 raised to 2 to the 6th. And this exponent is the exponent only of the common ratio. Again, take note. 6 here is the exponent of the common ratio. So 3 is not included. So therefore, if we have 2 raised to 6, that means you will take 2 as a factor 6 times. That's 2 times 2 times 2 times 2 times 2 times 2. And that gives us 64. So the 7th term is 3 times 64 or 192. So you could see whether we use the recursive formula or the explicit formula of a geometric sequence, still you arrive to the same correct answer. And if you got 192 as well, great job. I hope you got it. Now, let's have another example. Suppose you have 5, 15, 45, 135, and so on. Let's have this geometric sequence. Let's find a sub 8. You could actually see that the first term here is 5. We're looking for the 8th term, so n must be 8. And I believe you would agree that the common ratio is 3, because if you have 15 divided by 5, that's 3. 45 divided by 15 rather, sorry. 45 divided by 15 is 3. 135 divided by 45 is 3. So you have a common ratio. Indeed, it should have, because it is a geometric sequence. We're looking for the 8th term. For the 8th term, using again the explicit form and by substitution of these variables, you have a sub 8 equals 5 times 3 raised to 8 minus 1. Note that 8 minus 1 is the exponent of your common ratio only. 8 minus 1 simplifies to 7. And if you have 3 to the 7th, you will take 3 as a factor 7 times. Or you will you should multiply 7 threes. That gives you 2,187. But you have to multiply that to 5, which means the 8th term is 10,935. If you got this, great job. But again, you might be skeptical. Sir, how sure are you that this is correct? The trick here is simple. Since 8 is just manageable and you could have your calculators with you, you could verify this with your calculators. We have listed them. So these are the 4 terms. Continuing the pattern, 135 times 5, it's 400, by 3 rather, is 405. Times 3, it's 1,215. times 3 will give you 3,645 times 3 will give you 10,935. So you could see 1, 2, 3, 4, 5, 6, 7, 8. Indeed, 10,935 is the 8th term of this geometric sequence. And if you got it, great job. Exercises. Let's have the following. Feel free to pause the video from time to time and solve the problems and confirm if you got the correct answer. Given the geometric sequence with various givens, find the indicated term. A sub 1 is 5, n equals 4, your common ratio is -3, and you're looking for a sub 4 or the fourth term. I think this is pretty straightforward because all of these variables are given. So by substitution to our explicit form, all of these variables, you will have a sub 4 equals 5 times -3 raised to 4 minus 1. 4 minus 1 simplifies to 3. If you have -3 cubed, that means -3 times -3 times -3 or -27. Multiplying 5 and -27 gives -135. So the fourth term is -135. Thank you. Let's proceed to another one. Letter B. 81, 27, 9, 3, and so on. We're looking for the 8th term. Since we're looking for the 8th term, you could actually see here that the first term is 81. Your n is 8 because that's the subscript here. We're looking for the 8th term. And your common ratio is 1/3. Why? 27 divided by 81 is 1/3. 9 divided by 27 is 1/3. 3 divided by 9 is 1/3. So you could actually verify this with your calculators. So with these, by using the explicit form, so a sub n is equal to a sub 1 r to the n minus 1. You have a sub 8 equals 81 times 1/3 raised to 8 minus 1. This simplifies. I copied this one. I just subtracted 8 and 1. And from here, I knew the fact that 81, take note, you could actually use your calculators directly here. But in case you don't have calculators, here's a trick. I could express 81 in its prime factorization form, in exponential form, as 3 to the 4th. This is 1 to the 7th raised to all over 3 raised to 7. Because if you are raising a fraction to a certain exponent, then both numerator and denominator have to be raised to that exponent. That's why I have this one. And using the laws of exponents, your algebraic properties, it became a sub 8 equals 3 to the 4th all over 3 to the 7. Using again your algebraic rules, since the exponent, they have the same base, but the exponent in the denominator is bigger, so you subtract it. So that's a raised to 8 equals 1 all over 3 raised to 7 minus 4, or 3. And 3 raised to 3 is 27. So the 8th term of this sequence is 1 over 27. You could verify this by listing if you wish. Okay, letter C. How about the first two terms are -2 and -8? We're looking for the 5th term. Take note, if you have things like this, or if a problem is stated in this manner, it's understood that the word, or I mean the number before n is the first term, and the number after the word n is the second term. And you could see that a sub 1 is negative 2. Your n is 5 because we're looking for a sub 5. And sir, how did you get the common ratio? Remember that the common ratio could be taken by dividing a term by its immediately preceding term. Remember, this is the second term. This is the first term. So second term divided by the first term, it's your common ratio. Negative 8 divided by negative 2 is 4. So 4 is your common ratio. So by substitution here, we have a sub 5 equals negative 2 raised to, times 4 raised to 5 minus 1. The exponent simplifies to 4. And if you have a sub 5 equals negative 2 times 4 to the 4th power, 4 to the 4th power is 256. And multiplying these two gives us the fifth term as negative 512. I hope you got it also. Letter D, 90, 9, 0.9, 0.09, and so on. Is this still a geometric sequence? Yes. In fact, the first term here is 90. If you could see as well that we're looking for the ninth term, so n has to be 9. And your common ratio here is, if you see, 9 divided by 90, 0.9 divided by 9, 0.09 divided by 0.9, and so on is 0.1. Or if you wish, 0.1 as a decimal or as a fraction, that's 1/10. Now, supposing I'm going to use the decimal for now. Okay? So by substitution to this form, I have a sub 9. It's equal to 90 times 0.1 raised to 9 minus 1. The exponent simplifies to 8. And if you wish 0.1 to the 8th power, it's actually this number, 0.7, there's 7 zeros followed by 1. And multiplying these two gives you the ninth term, which is 0.00000009. However, suppose I'm going to utilize the fraction, the fractional value of your common ratio. So you will have 90 times 1/10 raised to 9 minus 1 still. The exponent simplifies to 8, so I just made it 8 and copy the rest. 10 to the 8, this one becomes 90 all over 10 raised to 8, which is 100 million. And this simplifies to 9 over 10 million. So if you answered as a decimal or as a fraction, again, both of them are considered correct. If you have any questions or clarifications, feel free to comment your questions in the chat box, or you may reach me through my social media accounts. With that, I give you this independent set, and the instruction is, given the geometric sequence with various given or givens, find the indicated term. Show solutions in a piece of paper. So take a look at, I give you 4 items, A, B, C, and D, and I believe they are parallel to the one I've given. And this will be passed. Today is Thursday, but I am giving you until Monday, October 3, to pass these. And I wish you all the best in doing this. Thank you very much, and a great day to one and all.